Hello everyone, this is Mr. Underkoffler. Today we're looking at the guide of notes called Probability of Compound Events, looking at the sample space. All right, follow along. A compound event is when two or more simple events are occurring. We'll see some examples of that today. The sample space, which we've talked about this phrase before, is the set of all possible outcomes in a probability experiment. To represent a sample space of a compound event, you can use organized lists, tables, and tree diagrams. Okay, let's start with an organized list. The spinner shown below is spun twice. Now, stop right there. Everybody highlight or underline the word twice. If the spinner was only spun one time, then our sample space would only have 4 outcomes, and this would be a really easy problem to do with probability. But since that spinner is spun twice, that is what makes this a compound event. The first event is the first spin, the second event is the second spin. Use an organized list or table to find the sample space of possible outcomes. Okay, I've already started this one for you, and this is pretty much both an organized list and a table. The table is helping us to get our organized list. So we have colors red, blue, green, and yellow, and yes, we are abbreviating. And for the second spin, red, blue, green, and yellow. So I've made columns of those colors and rows of those colors, and as you can see, this will then give us the sample space. We could get a red and a red, a red and a blue, a red and a green. So all of these start with the color red for the first spin. And then I can get a blue and a red, a blue and a blue. Fill these in with me as I say these out loud. I can get a blue and a green. I can get a blue and a yellow. So I hope you see all of these started with blue, and then the second letter was red, second letter was blue, second letter was green, second letter was yellow, and so on and so on. So go ahead and hit pause, fill out the rest of this following the pattern that I've shown you. Okay, did you already hit pause? Did you do the final 6 blanks on your own? If not, you better do that now and then hit play. All right, you should have had green, blue, green, 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 yellow, and then yellow, blue, yellow, green, yellow, yellow. All right. And the reason we can do this is so that we can actually see what the outcomes are in the sample space of spinning a spinner twice, a compound event. So it wasn't just 4 outcomes, and it wasn't 4 plus 4 giving us 8 outcomes either. If you look here, it's 4 times 4, which is 16 outcomes. Fill in that blank. All right, let's look at another example. And this is going to be a slightly different type of table than what we were using on problem number 1. Follow along. A number cube is rolled. You guys know what a number cube looks like. Has 6 sides, 1, 2, 3, 4, 5, and 6. A coin is tossed. Create an organized list or a table. Well, we're actually going to do it again. We're going to use the table to get our organized list to find the sample space of possible outcomes. Okay, the number cube can be a 1, a 2, a 3. Go ahead, fill this in with me. A 4, a 5, and a 6. Now, for the coin, you could get heads or tails, heads or tails. And notice I keep listing this for each of these that started with the number from the number cube. So you're going to have to go ahead and continue to fill this in on your own. But before you do, look at the sample space, which is the total outcomes from both the number cube and coin combined, because that's what we're looking for here. The outcomes of the compound event sample space. So starting with the 1, you could get heads. Starting with the 1, you could also get tails. And then going to the 2 in heads, 2 in tails. And then you'll go to the 3, and then eventually the 4, and then eventually the 5 and 6. So hit pause, finish filling out this table, and then hit play to make sure you got it right. Okay, did you already finish filling out this table? You should have had heads and tails continuing going the whole way down, because those are the outcomes for flipping a coin. And then for the sample space, 3 heads, 3 tails, 4 heads, 4 tails, 5 heads, 5 tails, 6 heads, 6 tails. Hopefully you had those filled in. And yes, you can see this is why we abbreviate things like heads, tails, red, blue, green, yellow. We abbreviate. It saves us time, but still being able to see the outcomes in the sample space. Now, you can also, I never filled in the blank. Notice this sample space has, well, it wasn't 6 plus 2 like you might have thought it was going to be. Oh, but is it 6 times 2? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, that is 6 times 2. We have discovered a shortcut for getting the total number of outcomes for the compound event. And by the way, I'm going to actually talk about that on the next page. But anyway, before we do, let me quickly show you the other way that you can do an organized method to get the outcomes in the sample space. It's kind of like this interesting looking table, but it's what we call a tree diagram. And would be a lot quicker to do than this very complex table. If you had to create this table on your own with a pencil and ruler, my goodness, that would take so much time. But a tree diagram, it's really similar to what we did here. You start by listing the outcomes of the number cube, 1, 2, 3, 4, 5, 6, then the outcomes of the coin, but notice it branches out from each outcome of the number cube. So very repetitive, like you saw here in this unique table. And then 1 in heads, boom. 1 in tails, boom. 2 in heads, 2 in tails. Can you quickly fill in the rest of this on your own? 3 in heads, 3 in tails. Why am I doing this for you? Hit pause now. Finish the rest of this on your own. Okay, did you already finish the rest on your own? If not, hit pause, finish the rest on your own, then hit play, and boom. It's the same thing you saw in this unique table. And again, there's all 12 outcomes in our sample space. Okay. The steps to making a tree diagram I have listed for you here at the top. The first step is to name the events going left to right. So that's what I did. We had the number cube, we had the coin, and then to the right of those, you're going to write sample space at the right end. Underneath the first event, you'll list the outcomes going down. You can abbreviate if needed, leave a lot of room between each outcome. Now, I didn't leave a ton of room, and the reason why is because I knew I only had to branch out to 2 outcomes for the coin each time, and I only had 2 events total. If I would have had 3 events, then I would have skipped more space. If the coin would have had more than just 2 outcomes, I would have skipped more space, so I had room for every branch that I needed. But this one, there was only 2 outcomes of the coin. But normally, you would want to leave a lot of room between the outcomes of the first event. And then from each of the first event's outcomes, you're going to branch out to the outcomes of the next event. You saw me doing that. You would repeat this for as many events as you have. Finally, you write the outcomes in the sample space column, and we already practiced doing that. Okay, now let's officially put in the blank here the shortcut for if you only need to find the number of outcomes, but you don't need to see the actual sample space, every single outcome in the sample space, then you can simply fill it in, multiply the number of outcomes of each event together. So back on the last one, we could take 6 outcomes for the number cube, 2 outcomes for the coin, 6 times 2, boom, 12 outcomes. For spinning the spinner twice, there's 4 outcomes in the first spin, there's 4 outcomes in the second spin, 4 times 4, boom, gives us 16. Not 4 times 2, just because we're spinning it twice doesn't mean we multiply by 2. It's 4 outcomes for the first event and 4 outcomes for the second event. 4 times 4 is 16. So that's the shortcut for finding the number of outcomes. Okay, problem number 3. A local diner's choices are shown in the table. A food critic asks for 1 appetizer, 1 main course, and 1 dessert to be selected at random for her to taste those things for an internet review. Create a tree diagram to show the possible outcomes in the sample space. Well, thank you, Mr. Underkoffler. You did this for us. Yes, I did. And you're probably thankful I did, because this was a pretty big tree diagram. I'm not going to lie. But we should not be shocked that if you count, there are 24 outcomes. Why should we not be shocked? Because remember the shortcut for finding the number of outcomes? Take the number of outcomes for each event, multiply them together. We got 3, 4, and 2. 3 times 4 is 12, times 2, boom, is 24. So that's a nice little way of making sure you have the correct number of outcomes in your sample space. Now, the reason I did this for you is because I want to have you do a problem where we actually use the sample space of our compound event from a tree diagram to find a probability. So here we go, part B, get your pencils ready, because this is not done for us. What is the probability that the meal will include crab ravioli and ice cream? I hope this problem's not making you hungry. If you think crab ravioli is a weird thing to have, trust me, from experience, I can tell you it is wonderful, if you don't mind crab meat. Okay, write the answer as a fraction in simplest form and as a percent. So as we already said, if you counted the number of outcomes, boom, there were 24 outcomes. But we are looking to find the probability that the meal is going to include crab ravioli and ice cream. So let me get my highlighter. You can go ahead and get out your pencil and circle. Oh, this one had crab ravioli and ice cream. This one also had crab ravioli and ice cream. And so did this one. I believe that's it. There are other choices that have crab ravioli. There's plenty of choices that have ice cream. But only those 3 have both crab ravioli and ice cream. So that's 3 out of 24. You're writing this down. That would reduce. They're both divisible by 3. Or you can just enter this in with your calculator's fraction key and hit enter. It'll reduce it for you. But easy fractions, you should be able to recognize that 24 is divisible by 3 and do this without a calculator. All right, 1 divided by 3 is 0.125. If you don't, did I say 1 divided by 3? I meant to say 1 divided by 8 is 0.125. You can test it in a calculator if you don't believe me. Move it to the decimal point 2 places to the right, and you will get 12.5%. Okay, I hope you wrote all that down. That was just an example of using the sample space to answer a probability question. And that's why I can't just have you multiply outcomes of each event together to get the total number of outcomes for a compound event, because that won't help you answer a probability question based on the sample space. We need to see the sample space in order to answer that question. Okay, there are 2 problems I would like for you to try. Number 4 is a tree diagram problem. And I know you're like, oh my goodness, we have to make a tree diagram. Yes, you do. But it's kind of similar to what you saw on problem number 2. Or sorry, I guess this was number 3. So feel free to look back at number 3 to use it as a guide to kind of get you started here on problem number 4. And then I would like for you to try problem number 5. This one, you're going to make a list using a table to find the sample space of 2 number cubes being rolled. And I'll give you a hint. It's kind of similar to the table that we made on problem number 1, where we had the outcomes going this way, and then we had the outcomes going that way, and then we were able to match them up, R and R, B and R, G and R, R and B, and so on. Very similar for the number cube, except the number cube would be, well, I might as well just go ahead and show you. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. There you go. You're welcome. I started this for you. Very similar to how we did problem number 1. And by the way, I guess I'll go ahead and start number 4 for you. Since we have video games, food, and drinks, those should be your headings. And then underneath video games, you're going to want to put their 3 outcomes, and you're going to want to leave a lot of space in between. Why? Because you're going to have to branch out 3 ways to the outcomes of the food. And then from each of the food, branch out 2 ways to each for the drinks. So again, I said it's very similar to problem number 3. So please feel free to go back to problem number 3. Now, there is, to use number 3 as a guide, there is a probability question for both number 4 and number 5. So when you're done making the tree diagram and you're done making the table for the organized list for the 2 number cubes, please don't forget to answer the probability question. Number 5, what's the probability of the rolling 2 cubes whose sum is 8? Sum means adding. And then problem number 4 wants to know the probability that a combination chosen at random will include a sports game and wings. These guided notes are making me hungry. I don't know about you. All right, so hit pause, finish all of number 4 and all of number 5 on your own, then hit play when you're ready to see how you did. Okay. Hopefully you finished your tree diagram. So the food was obviously pizza, burger, wings. Again, this problem makes me really hungry, and you have to show that from each of the 3 types of video games, the racing, the sports, and the adventure. Thank goodness we are allowed to abbreviate. And then from each of those food items, you went to the drinks, cola or juice, and you had it listed for all of them. And then finally for the sample space, hopefully you went, racing, pizza, cola, racing, pizza, juice, racing, burgers, cola, racing, burgers, juice, and so on, and so on, and so on. Boom. So we have this for our tree diagram and the sample space. And as you probably predicted, the sample space has 3 times 3, which is 9, times 2, which is 18. So there should be 18 outcomes in the sample space. 6 of them start with R, 6 of them start with S for sports, and 6 of them start with A for adventure. 6 times 3 is 18, so you should have a total of 18 outcomes. All right, the probability that we are going to pick a combination that has a sports game and wings. Sports game and wings, that's just those 2. I mean, there's lots of other ones that have sports games. There's lots of other ones that have wings, but only those 2 have sports game and wings. So that's 2 out of 18, which is 1/9, which is 0.1 repeating, which is 11.1 repeating percent. Feel free to hit pause if you messed up in any way, shape, or form. And finally, problem number 5. For the 2 number cubes, here is what your sample space should look like. I don't know if you have to put commas in between, but I thought it was helpful to put commas in between, so that way I didn't think I was looking at an 11, a 12, and a 13, and so on. So I thought the commas were very helpful. I know I didn't use commas in problem number 1, but here I thought it was really helpful. So if I were you, I would put commas on them real quick. If you need to hit pause to do that, feel free to. Okay, the probability of rolling 2 cubes whose sum is 8. 6 and 2 makes 8. 5 and 3 makes 8. 4 and 4 makes 8. 3 and 5 makes 8. Oh, do you see how it's a nice, cool diagonal pattern? Now, that was neat. All right, so how many was that? That was 5 out of, well, how many outcomes do we have here? You probably could have predicted it. 6 times 6 is 36. All right, 5 divided by 6 gives you 0.138 repeating, and that becomes 13.8 repeating percent. Okay, and that concludes the guided notes on probability of compound events, looking at the sample space. Thank you for watching. We'll see you next time.